Hello everyone. Today I'm going to show you how to convert a member into a meshable panel prior meshing. And then we will mesh it. So as you can see, I have a 4 meters length member, a beam member type. I'm just going to check on the section property I assigned. If I click on render model, I can see the shape of the section. Steel section IPE 200. Also, I can check on my supports. We can see it's fixed at both ends of the member. Now I'm gonna move to the loads window. I have defined a UDL along the whole member. So if we go to global projected load, we can see that I have assigned a -5 kilonewton per meter load to the whole member, distributed load. So I'm going back to geometry. With this tool, if I go to mesh, I can convert this member into a meshable panel. This is one way, or the other will be press Ctrl J on your keyboard. So if I click on it, S-Frame is going to ask you how many links you want between link I and J. I will request 8 links and click OK. As you can see, I have 8 links that were automatically created and the panel elements. If I go to the panel element tool, I can see that S-Frame automatically assign a shell mix mesh. This will generate rectangular, quadratic and triangular shells. If I would like to change to only have quadrilateral shells later, I can select the shell quad mesh and click and drag all over the panel. If you take a look at the thickness with this command here, you will see that the thickness of the member is just as the original. It kept the original thickness. I can see my mesh. It's about 5, and the seed density. You can change these details here and then select and drag all your member to see those changes. Now let's mesh this model. If I go to mesh and mesh panel elements, I can see a preview of what my mesh looks like. If you didn't like it, you can go back by clicking no and change the parameters, the mesh density, seed density, and so on. So I'm gonna click yes. I'm gonna accept this mesh. And now let's just take a look at the loads window. And now I want to display the loads. If I display the loads, I can see that S-Frame preserved the loads in the model once it's meshed, and at the edges the member ends are left in place to allow the definition of member releases, link elements, among others, but the forces are transferred to the shells using rigid body constraints. Now let's run an analysis. If I click, I'm going to run a linear static analysis. And now we can start looking at our results. For instance, we can take a look at the wall line assembly option. And with this tool, we can select the diagram's view options here, for example. This makes it easier for the user to compare with stick models. So you can take a look at the moment diagram in Y direction, for example. You can see it's 1.6 at the middle, the maximum, and check with your hand calculations. You can also go and take a look at the shell contours for different type of contours, including bone misses with color tabulated values. Thank you for watching. And for more videos, please subscribe to our YouTube channel.